Okay, good afternoon. Let's start. So in the last class we have done this insertion sort. So in that, what we are doing? So we had three techniques for sorting. Okay, so we have seen selection sort. In that, actually, we were finding the minimum index and minimum value in the list, and then we were interchanging with the first element of the list, and so on. So in the remaining, we were finding again minimum, interchanging with second. In bubble sort, we were comparing two consecutive positions, and if they are in order, it's okay. If they are out of order, then we were interchanging that, and in that way we were sorting the list. uh, in the third insertion sort, every list has two part. One is sorted part, other one is unsorted part. So like, we were selecting first element from unsorted part, and we were putting it into the right position in sorted part. So every time you were adding one element in the sorted part and from unsorted part, so at the end you will get sorted list. So that we have seen. Now we'll start with this linear search. So so this is searching technique. Okay, that was sorting. So sorting, we were arranging the values in ascending order. Now here we will search value in the given data. Okay, so what is saying? So first see this. In this method, we scan the list from the beginning till the required data value is found or the list is exhausted. So we scan the list actually from the beginning till the required data value is found. So we are searching for data value. So we will scan it from the beginning until the value is found or the list is exhausted. Suppose that value is not available in the list, then the list will be exhausted. So this searching technique is known as linear search. As the searching or search process is sequential. So like one by one we will be searching, we will be comparing the value with the each element of the list, and if it matches with that, so it's found. Otherwise, it is not there. So simple code we have for that. So we are defining a function linear search. Input parameters are here actually list we will have already, and search value. So what value we want to search? So there are two parameters. One is the list, and in the list we want to search this value. So two things we will be giving. So for loop we are using for I in range 0 to length of the list. So I is index. Okay, so for I in range 0 to length of list, if length list I, so means value in the list at index I is equal to, so double equal we are using because we are comparing search value. So search value is the value we want to search, whether it is available or not. If it is available, then what is the index of that value? So list I is equal to search value, then return I. So we are returning the index in that list at which the search value is available. And then return none, so we are returning that I. And then def main, this is the main part. So list we are giving as input, search value we are asking user to enter, and then calling the function this linear search, and then printing that. So here search value is actually that you will enter. We are just writing found at index, then search result. So index we are returning from that user defined function. That will do. So we'll have this. So this is code simply. Okay, so this code you may write. So what we are doing here, so same thing, okay, we are defining a function linear search and then a list and data. So data we want to search, so there is a value, so I'm writing data here. So that data, or you may write the value if you want, okay. So the value you want to search, so you may write it value you want to search, okay. So that value I have to write here, okay. So this not required. So for I in range 0 to length of the list, so I is the index, okay, we are scanning in whole list, okay. So I will take value 0 1 2 3, suppose I name it n. So length of the list, suppose I tell n, okay. So here we may write this we named as l, okay. So length of list I take, we take n. So I is index, so it will take 0 1 2 3, and I value will be till n minus 1. So last value of I will be n minus 1. So that are indices in the list. If list value at index I is equal to that value we are searching, then we'll return that index, okay. That is return none for the function. And because in the for loop we are checking it, list 1 we have given the list as input, then we are calling the function this linear search. Inside list 1 we are searching value 0. So you can check here parameter, here is the list and then a value you are searching in the list. So list 1 we have entered and then we are searching 0. Here list 1 we are entered, we are searching 8. So if it is not found, it will return none, okay. So if suppose that value is not found, then suppose I index is not available, in that case it will return none. So you please write this code everyone. So I think this is very easy code, just we are comparing list elements to the value we are searching, and if it is found then just return I, if it is not found then return none. So you please write this code, and if it is done, then you will write in chat. So I will ask you to. So okay, so you can see the code. You just write it, and if you're done, then you can write here in the chat. Okay, so have you done? Not. So anyone who have done, you can write in chat. Okay, just write it quickly. Okay, so I will ask your name. Madhumukhi, Pankaj, संदीप,
यस सर।
हो गया आपका ये?
सर बस थोड़ा सा बचा सर, बस लास्ट लाइन लिख रहे सर।
ओके,
2 मिनट दिए सर, 2 मिनट में हो जाएगा।
ओके। कुमार चंद्रशेखर, सुमित कुमार ठाकुर, प्रियांबदा साहू, तन्मय सिंह, आदित्य गुप्ता, अनिकेत नायक।
यस सर।
हो गया आपका ये?
सर थोड़ा सा 2 मिनट बस।
अभिषेक साहू,
Yes, sir.
हुआ आपका ये?
Yes, sir.
ओके, सो यू कैन शेयर स्क्रीन। ओके, So for the first, like in the list 0 is available. तुम्हारे लिस्ट में 0 भी नहीं है ना, तो दोनों में नन आया होगा। अच्छा, पहले में 0 तुमने सर्च किया जो कि नहीं है, और फिर दूसरे प्रिंट में 2 सर्च किया, दैट इज अवेलेबल ऑन इंडेक्स 1। ओके ओके, थैंक यू अभिषेक। अनुराग अल्बर्ट, सौरभ कुमार। Okay, so this was linear search. Linear search is very easy, just you are searching linearly. So you are comparing your value with each element in the list. Okay, so you are searching. So like if I show you the execution, so we may take it. So we are visualizing this.
सर
Hmm.
सर कर लिए सर।
Okay, okay. So I will tell you. Yes, okay. Okay, this is a program. So function is linear search. List we have given this list 1, 1435706, and so value actually list, this first parameter is here, and value we have assigned here 0. Okay, so list 1 and value is 0. So 0 we are searching in the list 1. So it is starting from here. N is the length of the list, so length of the list is 8. So here you can see N is 8 and value is 0, I is 0. So this for loop is getting started. So I can take value 0 to 7, right? N is 8, so 0 1 2 3 4 5 6 7 I will. So in the first iteration I will take value 0, and then if it will check the list at 0th index is equal to value, so list at 0th index is 1, so 1 is equal to value, value we have given here is 0, so value is equal to 0, no, so it will not return I, then in that case it will not found. Check here, so it is that condition is not true. So if condition is not true, then it will come out of loop. Then again it will go for second iteration. I mean sorry, when it is not found it will go for next iteration. So now it will go for next iteration, I is equal to 1. Again it will check whether list 1 is equal to value. So list at first index is 4, 4 is equal to 0, no. So again this if condition is false, so it will go to next iteration. Then I is equal to 2, again list at second index is equal to value, so list at second index is 3, and 3 is equal to value 0, no. So again if condition is false, so it will go for next iteration. So I3, then I3 list at third index is 5, 5 is equal to 0, no. So again it will go to next iteration. So I will be now 4. Okay, so it will go to next iteration, and I is 4, so list at fourth index which is here 0 1 2 3 4, it is 7, 7 is equal to 0, no. So again it will go to next iteration. I is 5, so I is 5, so at fifth iteration is value is 0 1 2 3 4 5 9, 9 is equal to 0, again if condition is false, so it will go to next iteration. Now I is 6, and at sixth index, list at sixth index that value is 0, so it will match with the value 0 actually, so it will return 6. So see, return value is 6. So like if condition is true in this case, so if condition is true in this case, so it will return I. So I at index 6, list at 6 index is equal to value. So if we return 6, okay, so 6 here is the output. So final output is 6. Okay, so that is the visualization. Okay, so now this was linear search. Okay, so this was linear search. We were searching value in the list linearly. Oh, okay, if it is not found, then like you can visualize that also. So suppose I edit this, instead of that 0, if I write, what do you want to search? Suppose I want to search 8. Okay, 8 is not in the list. Then we'll see. So this function linear search, and list 1 we have this. So value here is list that is assigned here, and value is assigned 8. 8 we are searching. N is 8, length of the list is 8, I is 0 in the first iteration. So it will be keep searching, and every time you know that 8 is not in the list. So since we are doing it on a smaller list, so it will compare with the 0th index value. So it will be false. For first index value it will be false. For second index it will be false, and so on. It will be checking for all, and at last it will not get if condition true in any case. In that case return none. So I4, I5, I6. When check here, I is getting increased. I7, I8. Now return value is none. Means if condition is never true in this case. Okay, for any value of I. So it will return none. So output is none. Means it is not found. Okay, it is. So you may print here. It is not found. So this is a linear search. Okay. So next we have is binary search. So there are two searching technique here we are looking. So first we have seen linear search. Now we have binary search. So okay, let's see what it is. So if the list to be searched is already sorted, so like the list you have in which you want to search some value, if it is already sorted, so like it is in ascending order, then we can use a faster method called binary search. So linear search work on any list whether it is sorted or not, but to apply binary search you need to have sorted list. Okay, so this point you may remember because in the MCQ they may ask. So to apply binary search you need to have sorted list. So first we examine the middle name of the list. So like if you have a list, you first find which one is the middle. Okay, since it is sorted list, so you find the middle one, which one is the middle element or middle value. If it matches with the name we are looking for, we stop. So like suppose we are searching for the value, and if it matches with the middle one, then we stop. And so like I can show you on. So in the linear search, what we are doing, simply suppose the list were like this, 5, 4, 8, 7. Okay, suppose 3. This is, so this is a list, and the value we want to search, suppose it is 7. Okay, so what will you do? So what we are doing, index you already know, indices are 0, 1, 2. So indices are 0, 1, 2, 3, 4. These are indices. So you have seen that for I in range, for I in range 0 to length of the list. So here length is 5, and we were comparing. So if list, So like it is list suppose 1 I say. So list 1 at ith index value equal to this value what we are looking. In that case it will return I. Okay, so now what will do, when I is 0 it will check whether that 5 is equal to 7. So answer is no, so it will go to next iteration. 4 is equal to 7, no. Then 8 is equal to 7, it is checking like this way one by one. So no. Then 7 is equal to 7, yes. So if condition is true now, so it will return which index, so index 3. So it will return index 3, so it will return 3, and you have seen this. And that you need. So at index 3 you have 7. But in the binary search what we'll do, first you need to have sorted list. Okay, so okay, suppose values are 1, 3, 5, 6, 7, 10, 12. Okay, and here you want to search. So what is the middle value, suppose like currently we are taking this. Okay, so this is mid. So this is a starting of the list, this is end of the list. Okay, this is mid here. So suppose you are looking for 6 only, and index like 0, 1, 2, 3, 4, 5, 6. So if you are searching for this 6 only, so if middle value is 6 only, 6 you are searching, so like value you are searching is 6 only suppose, and this is the list, then you will stop, only you will find that index. Or if it is not, suppose you are searching for 7. Okay, so now suppose you are searching for 7, then what you will do, so in that case first you see the ppt, then we'll explain through example. Okay, so first what is saying, so you have a sorted list and you are searching some value in that. So we examine the middle name in the list. So name it is telling because in the book they are taking list element as name, I'm taking as a number. So if we examine middle name of the list, if it matches to the name that we are looking for, so we stop. Okay, so that will return that index of the mid value. If we do not find the name at the middle position, we will only have to search on the left or the right side of the middle name, depending on whether the name at the middle position is greater or smaller than the name we are looking for. So instead of name, I will tell you this number. Okay, so suppose we are looking for 7. So middle value is what? 6. So where you will go, right or left? I mean, where you will search now? Right side you will search, or you will search on left side? Which side? We are looking for 7. Okay, so just you will first check the middle point. Middle point is 6. It is not equal to 7. So since the value we are searching is more than the mid value, more than the mid value, so value we are searching is more than mid value, so what we'll do, we'll go on right side. We'll go on right side, so we'll ignore left side now, we'll only check on right side. If suppose we were searching for 3, so then 3 is less than the mid value, then we'll go for left side. So every time the list length you are just doing half. Okay, so first time you are searching at middle, if it is not found, then you will compare, like the value you are searching is not equal to the middle one, then you will check whether the value you are searching is more than middle or less than middle. If the value you are searching is more than middle, so you will check on right side, and the value you are searching is less than middle, then you will check on left side only, and this process will be continued. So like uh, I was telling, if we are searching for 7, then we'll search here, and same process will be applied here now. Okay, on this list again you will find the middle value is 7 or 10 here inside this. So now you will inside that list, so what you will do, you will find the middle one again. So your middle one is 10 here, and now you are comparing, you are searching for 7. So now you'll see, okay, so again 10 is not equal to 7, so, but 7 is less than 10, so you have to look on the left side of the list, that middle value, left side of the middle value, because that value you are searching is less than the mid value, so you have to go for left side. Okay, if it is more than, then you will go right side, like that. And then you will go left side, you will search it, so it is single value, so it will be equal, so it will return that index. So look here, then I will show you the program also. So every time first we are matching the value, we are comparing the value we are searching with the middle one in the list. If the value we are searching is less than middle, will go into left side. The value we are searching is more than middle, then you will go on right side. Okay, so this point was this. To see how fast binary search works, so this is a there is a link with time complexity, so this you can check, so we don't require here, but we can see that. So like it is saying every time when you search and there your search fails, like, so every time if you don't find the value, so what you do to see how fast binary search work, we only have to observe that every time the search fails me, like if it is not equal to middle one, then the search interval is reduced to half. Okay, so like we were searching uh, here for 7 and middle one is 6, that are not equal, so only we have to look on the one half of the list only. Now either you will look toward right side or left side, depends on the value you are searching and the mid value. Okay, so that point is telling here that search interval is reduced to the half, only half. Okay, either right or left half, every in every iteration. Thus, in the worst case scenario, like we would require no more than a log n plus one step. So this is the time complexity of this binary search. So that we don't need here theoretically. Just for information, they are telling you. Okay, we will not be calculating here complexity, but they are telling that log n plus one is the log n plus one step. Okay. Okay, this is a program. So we'll try to understand what we are doing here. So we are defining the function binary search. The input parameters are list and the search value, like the linear search. So list will be given to you and the search value, so like you may ask from user what is your list and which value you want to search. Then here are the variables we are taking: low, high. Okay, so low initially is 0, like it is index, so low is 0, and high is length of list minus 1. Okay, that is the index. So you know, if length of the list is n, so largest index can be n minus 1, so that's why high we are taking. So that I was telling you here, start n, so that it is considering. Okay, so that index 0, if length of suppose list is n, so index, you know, like it will be 0, 1, 2, okay, and so on. The index will be like n minus till n minus 1. So that index we name here low, and this is we name here high. Okay, initially. So okay, so function we are defining binary search. Inputs are parameters are list and the search value. Low is 0 index and high index is length of list minus 1, that is n minus 1. Now while low is less than equal to high, so we are using while loop. That lower index obviously less than equal to upper index or high. Then what you said, you are defining mid. So mid is what? Mid, you know, integer value of low plus high upon 2. Low plus high upon 2, and we are you are taking integer, not float value. Sometimes it may be decimal, like 1 plus 2 upon 2. So 3 by 2 it will be 1. So we are 1.5, but when we convert into integer it will be 1. Suppose you have 4 values, suppose, right? For example, check if we have 0, 1, 2, 3. Okay, so in that case what is your low? So low is 0 and high is 3. So low plus high upon 2, so you will do, so it will 3 by 2, that is 1.5. So you will take the integer value, so integer value is 1. So this you will consider as mid. Okay, just we are defining in that way. If you want, you may consider this also, but we are defining this way. Okay, so if the length is even, in that case you will find like this case. If length is odd, then you will find like if you have a list with 5 element. Okay, index are 0, 1, 2, 3, 4. Okay, so here the low is 0 and this is low and high is 4. So low plus high upon 2, so that you will get 2. So this is the mid. Okay, This is the mid. So that we are defining here, mid is low plus high upon 2. We are contingent integer value, okay, not float. Now, so first we will compare the value with the middle one. So list at mid index, okay. So low, high and mid, these are indices, in index in the list. So if list at mid index is equal to search value, so inside the list you are checking at mid index whether it is equal to search value. If it is equal to search value, then you can return mid. So mid is the index, again we are returning that mid. So if mid value at index mid is equal to search value that we are looking for, then we will return mid. And if it is not like that, then we have to go into either right or either left, okay. So like what we are saying, if search value is less than the list mid, so if mid is not equal to search value, then there are two possibility: either search value will be less than the mid value or right than the mid value. So if search value is less than the mid value, means what? Means you will look into left side of that mid value, okay, so left half of the list. So search value is less than the list mid, so mid value in the list. And what you are doing now, so now you are updating that high to mid minus 1. So that index, since you know mid value is not that, so you will look into left side. So low is already 0, so you will restrict that high index to mid minus 1. Else means if search value is more than the mid value, if search value is more than the mid value, then you will go into right side. So in right side, high will be same, high will not be changed, but low you have to change. So low you can do mid plus 1 because you are looking into right half. So low will be mid plus 1. And if it is still not found, in that case return none. And this process will be continued till so every time list is getting half. So I will show you implementation of this in one example. And now here we are again defining a function. Defining function is sorted list. So here we are checking whether list is sorted or not, okay. So we are checking whether list is sorted or not. So def is sorted list. So function is sorted and input is list for I in range 1 to length of list. If list I is less than list I minus 1, so that's why it is taken from 1, okay, because I minus 1 will be 0 then. You may start from 0 to length of list minus 1. In that case you have to write list of I minus 1 is less than list I mean list I plus 1. List I is less than list I plus 1. That case you may write. If you start like range, write 0 to length of list minus 1. So it is returning 1 to this, so list I is less than this. So we are checking for sorted, okay. So if value at ith index, means next value, is less than the value at lower index, see out of order, so means what? List is out of order, then return false. It will check for each iteration, and anywhere it will found this, it will return false. And if it is not like that, then return true. Return true means it is sorted. If it return false means it is not sorted. And then in the main part we are asking user to enter the list. Then if not is sorted, so like if your list is not sorted, then print given list is not sorted. Else if it is sorted, then you are calling the you are asking the search value, so which value you want to search. So first you have to check whether your list is sorted or not. So because binary search will be applied over sorted list only, so you will ask the user to enter search value, and then you print that we are calling the function binary search list. So list is given here, and the search value you will ask from user, then will print. So I will show you this program here. Okay, so I can explain this once more here. So what I was telling here, suppose so initially 0 and n minus 1 I'm telling, okay. So this is low and this is high, and here somewhere suppose this is mid. So what you're saying, if you compare list mid is equal to the value you are searching, if it is, then you will return mid. Else, or elif, suppose the search you are doing, the value actually you are searching, that value is less more than, suppose list mid. Okay, so means what, value is more than, the value will be somewhere on the right side here. So value will be somewhere here. So value will be somewhere here, because value is more than list mid. Okay, so then what will do, so then what we are doing, so in the right side high will be same, just you low, this index is mid, so this will be mid plus 1, so you just update low by mid plus 1, and high will be same. Okay, and if value is less than list mid, okay, so there are only three possible, either equal or less or more. So if value you are searching is less than the mid value, then there you will look into this side, right? Value is less than, you will look into this side. So low will be same, low will be same here, you have to update high. So high you will restrict by mid minus 1, so this is mid minus 1. Okay, this is mid plus 1, mid minus 1 index. So index I'm telling. Okay, so you may write above mid minus 1, here the index is mid plus 1, so high is mid minus 1. So it will be keep going. Okay, again inside that, again it will repeat the process, again find mid. If it is found, okay, not found, then it will check whether the value is on left side or on right side. According to that it will update, है ना? If it is on left side, so high will be updated by mid minus 1. If it is on right side, the low will be updated by mid plus 1. It will keep doing, है ना, until it finds the value or list is exhausted. Or if it is not there, otherwise return none, it will return none in that case. So this was example of linear search only, same program, just I changed the list I've taken as a name, then we are searching Ruby in that. Okay, so this was telling you indexes 2 where Ruby is found. So that is example. Now we will come to binary search. So this is actually just pseudocode type. Okay, that it is telling, okay, by you find you just define a function binary search. If value at mid is equal to search value, then print search is successful at mid. If search value is less than mid value, so you will go on left side, so perform binary search in the left of the mid. And else means search value is more than the mid value, then you will search on right side, so perform binary search in the right side. Okay, that's like, here is a program. Okay, so here what we are doing, we are defining a function binary search. Parameters we are giving list and the search value, so like the value we want to search. Low initially is 0, high is the length of list minus 1. So you may write n if you want, है ना? So length of list you may write, है ना? So like you may write n is the length of list. So this one. So n we are defined, length of the list, n is length of list we assumed, and the low index is 0, higher index is high n minus 1. So while low is less than equal to high, okay, so low will always be less than equal to high, so it will be searching. Then mid is the low plus high upon 2. Okay, so mid is the low plus high upon 2, and we are considering integer value. Okay, so because it is index na, mid is the index, so it cannot be float. Again now we are checking whether list value at the mid is equal to search value, then you will return mid index. If search value is less than, so you will go on left side. In left side, high will be reduced, updated by mid minus 1. And if search value is on the right side of the mid, So you will update the low by mid plus 1. And if it is not found like list exhausted or other, so in that case it will return none. This is to check whether list is sorted or not. So def is sorted is a function in the list for I in range 1 to list length of the list. If list I, so ith index is less than I minus 1th index, so I minus 1th index is left side, so that value is more. Okay, so we may write it plus 1, and here we may start with 0 and length of list minus 1, so that is 0 and length of list minus 1. So you may write it. So we are checking this now will do more than. So list at index I is more than list at index I plus 1. So like left value is more than the right. So you are comparing two values in the list, two consecutive values you are comparing. So if somewhere left value is more than the right, means list is not sorted. And we want an increasing list. So we return false, else return true. So give the see. So in that case, first we'll read that. Yeah. So we are checking whether list is sorted or not. So it is telling the left value is more than right value. So means list is it is out of order. Out of order means, so here you are checking list out of order. Return false, else return true. Now list we are giving 1 2 4 6 8 2. Check here. It is a sorted list. No. Or you may write eval function. Okay. So I'm just giving the list here. So 1 2, this is not sorted list because after 8 you have 2. So see here, 8 is more than 2, so this condition is applied, so it is false, that's why. So if not is sorted, like this function, so is sorted is checking whether it's a sorted list or not. So if it is not sorted, then you print given list is not sorted. Okay, and else if it is sorted, then check, give me the search value, which value you want to search. So like we want to search 0, so let me make it, first I am showing you this is unsorted list, this is not, so let me sort it. So chalo इसको 12 कर देते हैं. So now it is sorted 1 2 4 6 8 12, and now we are searching 0, so it will print search value found at index, that index will return. But you know where here I am searching 0, but 0 is not in the list, so it will return none. 0 found at index none, so none means no index is there at which 0 will be found. So let me check, and if it is 0, let me check 4 12. So now if I run, so 12 found at index 5, 12 found at index 5. So 0 1 2 3 4 5, 0 1 2 3 4 5. So at fifth index you are getting this. Okay, so there are three situations here. List may be unsorted, or it is sorted, then value may not be found if it is not in the may not be found, or if it is found, then it will return index. Okay, so please write this program. You first write the half part here. Okay, now it is visible, so whole program is visible here. Yeah, so everyone please write it. I will ask your name. So this is binary search. Every time we are checking the value equal to mid value, not, then either going to right or going to left. The necessary condition required is list must be sorted. So please write the code, and if you are done, then you write in chat. Okay, so only Aditya have done till now. Others, please complete. What, what about others? No one has done till now. So ideally I have to check whether or not. Well, now it will be visible in single tab. वैष्णवी वैष्णवी ठाकुर. शिवम सिंह. अश्वनी कुमार. शुभजीत कर.
यस सर.
हो गया आपका ये प्रोग्राम?
ना सर, मोबाइल में कर रहा हूँ इसीलिए लेट हो रहा है थोड़ा.
ओके. संग्राम. हर्षिता. आयुष्मान. बसंत. शशांक. सीजल.
यस सर.
हुआ आपका ये प्रोग्राम?
सर शशांक. यस सर.
सर अभी थोड़ा सा है सर, अब थोड़ा बाकी है, लिख रहे हैं.
लिखो इसको. हाँ जी शशांक, व्हाट अबाउट यू?
Sir, I'm writing the program, just the last part.
अच्छा, स्वप्ना श्री हैज डन. ओके.
Yes.
स्वयं सार्थक. कृति.
Yes, sir, doing it.
ओके. अनिकेत. सौभाग्य शंकर. आकाश कुमार. ओके. ऋषि कुमार झा, आई थिंक यू हैव आल्सो डन. ओके. स्निग्धा.
Yes, sir.
अमिताभ. आदित्य सिंह, थिंक यू हैव आल्सो डन. अभिषेक मिश्रा. ईशान राज. लिप्सिता. आदित्य कुमार सामल. मधुस्मिता. आयुष. रविराज यादव. सेजल राज.
यस सर.
हो गया आपका ये?
सर बस लास्ट वाला चल रहा है.
सब्यसाची. मोनिका. सौम्य सौरभ, अब्दुल्ला तवीस, अभिलिप्सा, आदित्य नारायण, प्रतीक्षा, सदान हसन, सत्या सुदर्शी,
सर कर रहा हूँ सर।
ओके, प्रियजीत, अभिषेक, अभिषेक पंडा।
प्रेजेंट सर।
हो गया आपका ये प्रोग्राम?
यस सर।
ओके,
हो गया। तो शेयर।
यस यस, यू कैन शेयर।
यस। Yes, sir.
Okay, so what you are searching?
Try to return the index value of the element.
You are searching 7. Okay,
Yes, sir.
7 you are searching in the list. Yeah. So you are getting 6, and B you are searching 15. So 15 you are getting -1.
Yes, sir.
Okay. So okay, you are returning -1 in that case if it is
Yes, sir.
not found. Okay,
Yes,
okay. So like I have written none. So okay. Yeah, yeah. Okay. Thank you, Abhishek. Yeah, fine.
thank you, sir.
But -1 may not create problem. Like -1 means what?
Minus. It means
In
I mean
index.
I can instead write none. Like if there would have been true or false, then I could have written false.
Because sometimes -1 is also an index, is it?
Yes, sir.
Yes. So that may create confusion.
Yes. So this might be valid only for the positive integers.
Yes. So if you are considering only index positive, then in that case, or non-negative, then in that case it's fine.
Sir, I'll rectify this.
Okay. So we can visualize it on Python tutor also. So let's see for this. Then I will also manually explain how it is working. So the list currently, first of all, let's take unsorted list. Okay, like initially I have taken, suppose take unsorted. So it should give given list is not sorted. Okay. So initially we are here. So is sorted function came here, and because it will start from here, na? So one function we have bind search, other function we have is sorted. Okay, there are two functions we have defined, bind search and is sorted. And now list value, this is the list value we have. So what is it doing? So first here hai na, we are doing if not it's sorted list. So like if we are calling that if list is not sorted, then print this. So first it will run in that. So it is checking whether it is sorted or not, list is sorted or not. So I is 0, and then it is checking. So I is 0 means list at 0th index, it should be if it is more than list at first index. So means this condition is false here when I is equal to 0, because value index when index is 0, the value at index 0 is 1 and value at index 2 is value at index 0 is 1, value at index 1 is 2. So this one value is not more than 2. So if condition is false, so here it will not return false. So it will keep checking when I is 0, I is 1. So for I is 1, it is also, if condition is false. For I is 2, it will be false. So when like I is equal to suppose 4. So in that case, value at fourth index is more than value at fifth index. Yes. So this if condition gets true and it will return false. So means it is not sorted. Okay. Then if it is not sorted, then you print given list is not sorted. So I4, you can see here iteration is getting increased. I4, then it will give I5. So but I4 you will get false because at I4 the value at ith index is more than value at I plus 1th index. So it will come here now. So it was checking this function is sorted, and now it returned false. So in false case, it will return given list is not sorted. So it will print you check here. So output here is given list is not sorted. Stopped here only. Okay. So now stopped. Now we will edit that. So because we have given that unsorted list, now let's give sorted list and search the value. It is not available. Like 14, I'm searching. Check what it will do. Just note how program is being executed. So binary search is one function, is sorted is other function, then list value, then again it will check because first it green line you can see green arrow. So means we are here currently, and red line is the next line. It is telling also line that we just executed and next line to execute. Okay. So now we're starting again. Okay. So binary search is one function, each sorted other function, then list we have, then here this function gets started. Okay. And it is searching whether the list is sorted or not. So again you will say I is 0, like 1 is less than 2. So this if condition will be false. 1 is less than 2, 2 is less than 4, 4 is less than 6, 6 is less than 8, 8 is less than 12. So list is sorted. So that will return true. Yeah, so that you can see here when it was checking function is sorted or not. So return true means that list is sorted. Okay. So here this if part I'm talking is false. Okay. So it is not sorted, no. So it is sorted, so else part will be executed. So this else part will be executed. This will be now executed. Okay. So check here, else part is getting executed, and now it will search that 14 in the list. So list we have this and searching 14 here. So it is searching 14 in the list. So how searching is here? So n is length of the list. So n is 6. So length of the list is 6. Then low value is 0 we assigned, and high value is n minus 1, that is 5. So low and high are in index, and then since low is less than high, so mid value will define. So mid value is 0 plus 5 upon 2, 2. So mid index is 2. Okay, here is mid index because there are even number of elements in the list. So mid index here like we defined is index is 2, mid index is 2. Then what it will doing? So it will be mid find. It will check whether mid is equal to search value. So mid value is 4. Okay, and search value we have given 14. So it is not equal, so it will go to next step or next line. So now it is checking whether search value is less than mid value or more than mid value. So So check, mid value was 4, so search value is 14, so 14 is more than 4, so it will go to right side, and that's why check here, mid is 2 and now low is 3. Okay, that low is 3, mid plus 1. When you go on right side, low you update by mid plus 1. So mid was there, mid was 2, so low plus 1 3 and high is 5. Now it will be, now again in this way it will calculate mid. Now 3 plus 5 8 upon 2, so see mid will be increased now. So 8 5 plus 3 plus 5, now inside that list, in this list only they are working. So mid is 4 now, this mid is 4 now. Again mid will check that the value at the mid index is equal to search value. Search value is 14 and mid value is 8, not equal. So now it will check whether the search value is more than mid value or less than. The 14 is more than 8, so it will go on right side. So again low will be incremented by I mean updated mid plus 1. So low will be 5 now. Okay, so check here, so low is getting increased by 5 and our high is already 5. So because at the end we have a list of one element, that's why. Again it will check whether this 12 is equal to 14. No, so now it will return false. Sorry, hey, here it will check, then it will return none. So if it is not found, it will return none. That's easy. If it is not found, it will return none here, this. So return value is none because 12 is not equal to 14 and search completed. So final output is 14, the value we are searching, found at index none. So there is no such index. Okay. And similarly, if I edit one more time, like if I want to search the fourth, suppose instead of 14, I search 4. So again, similar way, two functions are there, list, it will check whether list is sorted or not. So currently it is checking whether list is sorted or not. So list I must be less than list I plus 1 to be sorted. If it is not, then it is not sorted. Then list is sorted. So that true means list is sorted. Okay, so it was checking list is sorted or not. So it is true means list is sorted. And then now it will start searching. So it will search for, okay, and so when it will start searching, so first it will check for mid. So what is n is the length 6, low is 0, high is 5, and now low is less than high. Yes, so in that case while loop will be executed, mid it will find. So mid is 0 plus 5 upon 2, again 2, mid 2, and that mid 2. So value at index 2 is 4 and we are searching 4 only. है ना, value at mid index is 4 and we are searching 4 only. So it will be uh, it will return mid. So this part will be true, list at mid index is equal to search value, so it will return mid. So see, return 2. So at second index you found that. Okay, so it found 4 found at index 2. Suppose you were searching instead of 4 you were searching like 2 or anyone. Okay, so like 2, if I do one more time, so for 2, so we are searching 2. So when they search insert sorted, then list we have, then again it will check whether list is sorted or not. So every time it will check. So here true means list is sorted. So it checked whether list I is more than list I plus 1. So if this happens means it is not sorted, but list I is always less than list I plus 1. So that's why it will return true, and that is sorted. And then now it will be start searching 2. So start searching 2. So search value is 2, n is 6, low is 0, high is 5, mid is again 2. Now value at index 2 is 4 and we are searching 2. So 4 is a mid value and search value is 2. So 2 is less than 4, so we'll go on left side. So we'll only consider this list. So then high will be reduced by mid minus 1. So high will be mid minus 1. Check. Mid was 2, so high is mid minus 1, that is 1. And low is 0. So this list of 2 element. And now you will find again update mid. So update mid high plus low by 2, 1 plus 2 upon 2. So 3 upon 2, 1. So at index 1, you will value is 2. Okay. One minute. So what is it? So low 0, high 5, okay, and mid 2. Then will search 2 is less than 4, the search value less than mid value, so go on left side. And again high is now reduced by 1. So okay, low is 0, sorry, low is 0 and high is 1. So mid now will be 0 plus 1 upon 2. So 1 upon 2 means 0, it will come, integer value will be 0, so mid will be 0 now. So mid is 0 is this one. It will check whether this mid value is equal to search value. No, search value is 2. So now it will consider the right half, I mean after this, and this will be taken. So in the list, so low value updated by mid plus 1. Mid is 0, so now low value mid plus 1, so low will be 1. Yes, so low is 1 now, and low is 1, high is 1. So now it will compare. Okay, so mid, if you find 1 plus 1 upon 2, so mid will be 1 also. Yes, and that value is equal to 2. Yes, so it will return that index 1. Return value is 1, so you found that index 1. Okay, so 2 found at index 1. So that is here. So I hope you got the concept. Like if I explain the same thing here, so if you are still someone has problem, you may ask. I think you got the point. So what we are doing in that, 2, 3, 8, 9, 10, 12. This is sorted list, and suppose we want to search for 10. So value we are searching is 10. Okay, so what you'll do, first you will find the mid. So low initially is 0, high initially is length of minus 1, so length is 1 2 3 4 5 6 so 5. So mid in that case you will get 2. So what you will check the value, so 0 1 2 3 4 5. Okay, so value at mid, so value at mid index is 8. So 8 is equal to search value, no, so it will not return. So now you will check the search value, that is 10 is more than, so you will only consider this list. Again I'm telling this, you will only consider this list. So now the list you have this one only, you will list you have 9 10 12, only you have this list. So what happened, that uh, low value is updated by mid plus 1. So mid plus 1 means mid was 2, so 2 plus 1 is 3. So now low is 3 and high remains same. So high is as it is 5. So this is 3 4 5, this is. Now again you will find mid in that. So 3 plus 5 upon 2, that is 4th. So this is the mid value. And now it will compare whether your mid value, so value at mid index, so 4th index is 10. And 10 is equal to 10, yes. So value is 10. So it will return that index, index mid. So 4 it will return. So at index 4, you found this. And any value you can do. If you are searching 3, so whether it will go on left side, again you find mid value in that. Okay, so I hope you got this binary search, how it is working. So till now what we have discussed, in sorting technique we have discussed that selection sort, bubble sort, and insertion sort. In searching technique we have discussed linear search and binary search. Two more sorting technique we have, so that I will do in next class, not in today class. So I will take attendance, and if those who have still not done, please complete. I will ask your name, you have to share. So this program binary search, those who have not done, please do it now. So yes, Harshvardhan, स्वस्तिक,
यस सर।
ये प्रोग्राम हो गया आपका बाइंडरी सर्च वाला?
नो सर, कर रहा हूँ।
कब तक करोगे भाई? विवेक कुमार, सुमित, सोमेंद्रा, उज्जवल, अब बताओ किसका अटेंडेंस रह गया?
प्रसन्नजीत।
हाँ, सो प्रसन्नजीत, आई विल
सर
टेक
मेरा
1 मिनट 1 मिनट। प्रसन्नजीत, हैव यू डन दिस प्रोग्राम?
डूइंग।
तो उसके बाद जब कर लोगे तब अटेंडेंस मिलेगा। जिनका छूट गया, सो आई विल मार्क योर अटेंडेंस इफ यू शेयर योर स्क्रीन एंड यू विल शो दिस प्रोग्राम। नेक्स्ट बताओ, नेक्स्ट कौन है?
सर अभिषेक
अभिषेक, पूरा बताओ, पूरा नाम।
अभिषेक साहू।
हाँ, अभिषेक साहू, हैव यू डन दिस प्रोग्राम, दिस वन बाइंड रिसर्च?
यस सर।
ओके, सो यू कैन शेयर स्क्रीन। तुम्हारा तो अटेंडेंस लगा हुआ, तुमने पहले ही बोला है शायद, अभिषेक साहू। So those who responded earlier, your attendance is marked or present. Next, who is the next who have missed their attendance? Okay, so in linear search, what we were doing, we were just comparing the value, है ना? So like here, just we were checking list value at index I, search value, then return I, else return none. This was in binary search. What we are doing, low, high, and mid. Okay, so that mid every time, and according to that we are dividing the list into half part every time in every iteration we are doing just length half of that index. Okay, so if your value is equal to mid, return mid. If not, then you check whether search value is more than mid or less than mid. So if it is more than mid, then you consider only right half of the list. If it is less than mid, you consider only left half of the mid. Then in that case apply the same process, like low is same in the left half, low is same, high is updated as mid minus 1. If you go into right half, then low is updated because you are going right half na? So high is same, just low is updated by mid plus 1, and you are repeating this process till you find or list is exhausted. So in that case you will return none if it is not found. Okay, so that is here, or we can see the next part. So there are linear search and binary search. Okay, so next what we have, merge sort. So program I will show you next class, but merge sort and quick sort. So in the last class, next class we can finish this too, I think. So those who have not uploaded assignment 11, you please upload है ना solution assignment 11. Then I will share the link, and by 12th Feb you have to update upload assignment 12 also. So you can check assignment 12. So what is that? I may, because two techniques we have. So let's see what is that.
So, what's the deadline for assignment 11?
It was today only, I think. 7th I have given.
Okay. So,
Let's
can
see.
you extend the deadline till tomorrow?
Okay, upload it till tomorrow, no problem. So today is what day? Okay, so Monday.
Thank you.
Okay, no problem. So you upload by tomorrow. And I think both form will be available till 12. So till 12 you can upload 11 and 12 both. Just you upload. So
Thank you, sir.
okay, I will share it. Yeah, so we are showing what is in assignment 12. So they are just in assignment 12, what they are asking, how many passes are required for the elements to be sorted in the insertion sort. Mentions of method. Passes means iterations. Okay, how many iterations are required for the element to be sorted in insertion sort. So you just remember the algorithm in insertion sort, and then you try to write. Then mention some method you can use to choose the pivot element in the quick sort. So quick sort we have not done till now. Okay, that two is remaining. So two like merge sort and quick sort is these two are remaining. Or what more we have? Mention some main idea that lies behind selection sort. So selection sort you know already. Following are some example of the list. Find out which one of them will work if we want to implement binary search. So binary search you have seen today only, है ना? So mid, low, high. So we were just in every iteration we are just doing updating list and half of the list. Like it will be found at mid or at right or left. So in that it is telling search element -9. Here you search -10. Here you search 4, like that. Develop a program to sort the employee data on the basis of pay of the employee using a selection sort, bubble sort, insertion sort. Consider a list L containing object of the class employee having employee number, name and salary. So in the list you have this many data. Write the recursive version of the linear search. So linear search we have done today just we were just comparing list I is equal to value that we are searching, and binary search algorithm discussed in the text. So you try to write the recursive version of that linear search and binary search. Consider the list this, write the iterations of bubble sort that we'll do in next class. Then rewrite selection sort, bubble sort, insertion sort function using recursion. Okay, so one way you can do like we were doing using for loop and all that. Other way is using recursion. So you have to write using recursion. So that are all. Okay. So write a program for the binary search for the sorted list in descending order. So binary search we are doing today only. So just what you will do, if it is descending order, then value is more, then you will go on left side, right? Like currently what we have done today. If value is more than mid, we go on right side. But in descending order, if value is more than that, you will go on left side. So just you will update mid. Currently what we have done today, if value is more than mid value, search value is more than mid value, so you are updating low by mid plus 1. In that case you will do update a high by low minus 1, like high by mid minus 1. So what you are doing for right side, you just do opposite. So elif and else condition will reverse. Okay, there are 12 questions in that assignment. So I have shared already, so I have already shared with all ppts and all minor assignments with you. You have all 12 ppts and all 12 minor assignments, so you may revise because in the final exam you will be asked all 12 chapters. Okay, so in the next class I will do this rest part. So like two algorithm you more have, like a quick sort and merge sort. Then I will discuss assignment also, and then we can finish that. In the next class we may discuss some questions. Okay, so I think that's all for today, and I will stop here. Thank you everyone. Okay.
Thank you, sir.